Alright, today we're going to do a problem from chapter 17 where we're calculating delta G for this reaction at non-standard conditions at 25 degrees Celsius. The non-standard conditions are when the pressure of CH3OH gas is 0.855 atm, pressure of carbon monoxide gas is 0.125 atm, and the pressure of hydrogen gas is 0.183 atm. To find delta G at non-standard conditions, we use the equation delta G is equal to delta G naught plus RT natural log of Q, where R is the gas constant, which is equal to 8.314 joules per mole Kelvin, and T is the temperature in Kelvin, so we have to convert 25 degrees Celsius and add 273 to get 298 Kelvin. To find delta G naught, we use the equation the sum of delta G of the products minus the sum of delta G of the reactants. For this problem, we use delta G of carbon monoxide gas plus 2 times delta G of hydrogen gas minus delta G of CH3OH gas. Always keep in mind that you have to multiply delta G by the coefficient, so you can see that we multiplied hydrogen gas by 2 because it has a coefficient of 2 in the reaction. Using the values from Appendix 2b in the textbook, we found our delta G naught to be equal 25.1 kilojoules per mole. To calculate the reaction quotient Q, we use the law of mass action, which has the partial pressure of the products over the partial pressure of the reactants. So we have the partial pressure of carbon monoxide gas times the partial pressure of hydrogen gas. You must square the value of hydrogen gas because it has a coefficient of 2 in the reaction. We divide this by the partial pressure of CH3OH gas, and using the given values from the problem, we found the reaction quotient to be 4.896 times 10 to the negative 3. To ensure we have similar units, you convert the gas constant 8.314 joules per mole Kelvin to kilojoules, which gives us a final value of 8.314 times 10 to the negative 3 kilojoules per mole Kelvin. So now we plug in our calculated values into the original equation. So we have delta G at non-standard conditions is equal to 25.1 kilojoules plus 8.314 times 10 to the negative 3 kilojoules per mole Kelvin times 298 Kelvin times the natural log of 4.896 times 10 to the negative 3. Calculating this, we get delta G is equal to 25.1 kilojoules plus negative 13.179 kilojoules, which gives us our final answer, which is delta G at non-standard conditions is equal to 11.9 kilojoules. Always make sure you keep track of your significant figures.